Okay, hello, welcome back to another one of my video log recording sessions where I talk about genetic algorithms. Well, today's session, first of all, today is 2025, May 4th, and in today's session I will be circling back to the to how the summed utility values for entities for the top 10% change change in respect as the max constraint percentage changes from 0.0 to 1.0. Notice how I stuttered and how I didn't know what to say, and that is due to the fact that it has been about a month that slightly less than a month that I dealt with this, because after having done this I moved on to after having done this one on the left, I moved on to trying to find a better evolution scheme, which I did, and about which I also made videos after that one, and then having found the new or better evolution scheme, I modified the code and then I ran everything on AWS this time instead of Google Colab Pro Plus. So on the left, with the old evolution scheme, it was done on Google Colab Pro Plus. On the right, I ran it on AWS, and TLDR, it took a lot longer to run everything on AWS because since everything was being done on the CPU, and the CPU that they give you with the free tier is just absolutely horribly slow. So it took about 15 days to run this. So yeah, it was either that or spending another $120 on Google Colab Pro Plus. So as I weigh my options, I don't really know which one is better. One is too expensive, the other is just too slow. But anyway, I got the results, and in today's session I'll just be talking about these two results, how the peaks and the plateaus changed over different max constraint percentages when the utility values and the constraint values were sampled separately, but from different types of distributions. So let's get to it. So we've seen this when both the utility values and the constraint values were sampled from normal distribution separately. And I also cover this in one of my previous videos when I only did the 8 different distribution types: normal, log normal, uniform, exponential, von Mises, Pareto, variable, and left skewed. But now there are other 56 more distribution products, I should say, that I need to cover. I need to record and cover. So I'll be doing that. So we'll just skim over this. The first one, normal. We see the plateau here as well. It's a different type of plateau that you would get in a some utility score, but in this case, the dip size and the peaks and the plateaus are just stagnating, and this is what I wanted to fix, which I did in this case. But we still do see this slight slacking off right at the end with 100 genes or 100 items, and I've also mentioned that this can be fixed by having a bigger population and inserting more newborns into the world or population within that generation. But it does require more computing resources. So anyway, that's how the well, they're different now. See how it was 10,000 the maximum total utility value, and it was coming nowhere close to 8,000 even. It was at around 6,000. Now, even with 100 items, the peaks and the plateaus, the peak being the yellow line or the gold line, the blue line being the plateau level, comes all the way up to 8,000, even when it's stagnating with 100 items. But for 40 items, you see that on the right is the better evolution, the new evolution scheme, and on the left is the old one. And with the new scheme, you see that it continues to increase. The slope never falters. Well, kind of, it does kind of here, but you get the point. As the max constraint percentage goes up. So it is doing what it was intended. For normal and log normal, first one being the constraint utility values, and the second one being the constraint values. And you see that with the new evolution scheme, this is also apparent. Although it does have a different shape, kind of, you see that it keeps on rising. The levels keeps on rising. For 10 items, for 40 items, it was very apparent. It was very evident that it just stagnates and it just doesn't go up as the maximum constraint percentage goes up. So we got that, but instead, with the better new evolution scheme, we got this. It's an M-shaped thing, which is which we'll kind of see quite often. And with 100 items, this sickle-like graph is, the sickle's still kind of there, but it's more of an M-shaped, like McDonald's. But yeah, you see, we can still see the peak levels and the plateau levels kind of going up. But I know that the slope here compared to here is smaller, but this can also be fixed by introducing more newborns per generation. Normal uniform, 10 items, yeah, kind of similar, but you see it's already slacking off. And for 40 items, now this is different, yeah. It keeps on going up. And 100 items, normal uniform, 100 items, it also keeps on going up. So it's as if we have, I don't know, it's as if we took this apart with our hands, and then kind of yeah, twisted it upwards like that, which is why we get this. So the shape kind of remains the same, the overall shape. Because if you just rotate this, you get this. If you rotate it like that way, rotate it that way slightly, and you get this. Kind of like a sickle. So normal uniform, we got that covered. Normal actual variate, again the same. But so what the new evolution scheme does is exactly what I just said. It takes the end bits and then twists it upwards, or kind of pries everything upwards, so that the peak level and the plateau level is higher as the maximum constraint percentage goes up. For 40 items, yep, we see it. For 100 items, we do not see this anymore. But what's interesting here is that we keep getting these small trenches, or small rifts. I don't know what I should call it, but yeah, that keeps on reminding me of McDonald's. Normal Vermeer, 10 items. Yeah, kind of similar, but you know, again, weaker, lower. For 40 items, now this is the difference here is very, big. This wasn't really working, but now this works. And again, we again have that, slight dip, this rift. For normal Pareto, we have these steps for 10 items. Well, we did do that. We did have those steps in with the older evolution scheme, but now you see that when this happens, it's not working. Like, oh god, when you have these bits, as the maximum constraint percentage goes up, and when you have these levels not going up as intended, well, not as intended, that already implies, but anyway, not going up in accordance with the max constraint percentage, something, well, you should think that something is wrong, as something was not wrong with the new evolution scheme. Yep. So 40 items, yep. Normal Pareto, 100 items. See? Again, towards the end, it's not, something is off there. Which for which I am mentioning this solution for the third time. Introduce more newborns, or have a bigger population and then introduce more newborns, or etc. Normal Wavell. For 40 items, yep. For 100 items, so everything is working here. For normal left skewed, yep, 100 items. Again, slight slacking off towards the end. Log normal, these steps for 40 items, yep. For 100 items, yeah, that's kind of pretty. Log normal. Notice how I changed the spelling for log normal, because I just, it makes me, it makes my life easier. Log normal, yeah, we have these steps. Log normal normal 40 items. We have the M-shaped. We have the sickle here. Now we have an M-shaped graph or plot. Log normal expo variate. No, log normal uniform. 10 items. 40 items. 40 items. Yep. Log normal expo variate. 10 items. 10 items, 40 items, and 100 items. Okay. Log normal Vomises. Yeah, we have these steps. 40 items, 100 items. Yeah. Log normal Pareto. 10 items, 40 items. Yep, 100 items. Yep, we have that. Log normal Babel. 40 and 100. 10 items, log normal left skewed, log normal left skewed, log normal left skewed 100. Yep. Uniform normal. See how, notice how we keep getting very similar shapes. Oh god. Where are we? Uniform, log normal. There we go. Yep. Uniform log normal. There we go. Compare these two. Uniform log normal 40 items. Yep. 100 items. Okay. Well, it seems that when we have uniform log normal, maybe we need more. We need a bigger population, starting from 40 items. That's unusual. Well, it's a bit different. I wouldn't say unusual. Uniform. 10 items. 10 items. Yep. 40 items. Okay. 100 items. Okay. So everything is kind of working as expected. Ten items, 40 items, 40 items, and 100 items. Okay. See, we keep getting these towards 60%, and then it starts going back up again. See, the same thing at 60. So something weird always happens at around 60. That didn't change. Because I remember saying that interesting things happen when the max constraint percentage is at around 60 or 70. But as you can see here, these small crevices or trenches, these small slight dimples always happen. Very interesting. Regardless of what the distribution is, well, not that regardless, but as long as it's not something like normal and left skewed or normal, when it is a normal distribution, that I don't think that actually happens. When the utility values are sampled from a distribution that behaves like a normal distribution, or that can act like a normal distribution, these dimples don't seem to happen. Normal uniform label. Where is it? There we go. 40 items, uniform label, 40 items, uniform label, 100 items. See, it's always at 60. Uniform left skewed. Yep. It's always at 60 somehow. I don't know why. Maybe I did something wrong. That would be dreadful. Okay. Expo variate log normal 10 items. Expo variate log normal 40 items. 40 items. Yeah, now this is, well, if you just look at this alone, you might say that, oh, something is wrong, something's definitely wrong. But if you compare it to this, it's a lot better. See how the peaks and see how the peak levels and the plateau levels actually went down, went lower, given 40 items and 100 items. But with the new evolution scheme, that didn't happen after max constraint of 60%. It did go down a bit, but it came back up. I know it could have gone, higher, but still it didn't end up being lower. Same here as well. It still kind of maintained. It is kind of a bit lower, but again, this is probably because it's 100 genes, and I only had like 1,000 entities in the population, so a bigger population would solve that problem. Is it a problem though? Maybe, maybe not. Expovariate uniform, 10 items, 40 items, uniform. Maybe with expovariate, with the exponential distribution, maybe this happens with that, but only with exponential distributions, or things like exponential distributions. Maybe. Exponential Pareto. Exponential label. Okay. Exponential left skewed. Okay. For Mesa normal. That's really weird. For Mesa log normal. Okay. 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 Cool. For Mesa uniform. Okay. For Mesa expovariate. 10 items, 40 items, 100 items. Okay, for Mesa. We've seen this, but I'll go over it anyway. Still a lot better. Keeps on rising. The levels keep on rising. Oh god. Where are we? For Mesa Pareto. For Mesa Pareto. 40 items, 100 items. For Mesa label, 10 items. Yep. 40 items, 40 items, 100 items. So it seems that when the utility values are also sampled from Mesa, they work like they behave as if they were also sampled from an exponential distribution. Kind of similar with Pareto as well. Not that much, but yeah, kind of similar. Now this is a huge improvement. As the levels just went way down. But with the new evolution scheme, that didn't happen, except this small dimple. Parto, 10 items. Okay. 10 items. Okay. 10 items. Alright. Oh god. That's really annoying. Items, okay. Variable 10 items, variable 10 items. Yeah, we've seen this. I've covered this. But, anyway. Variable left skewed. I'm almost there. It's not easy going through 192 plots. Very tedious. I hope it's worth something. Left skewed normal, left skewed normal. Yep. Why do I keep doing that? Left skewed, left skewed uniform. Low normal, yep. Low normal, left skewed, low normal. 40 items, 100 items, yep, improved. Left skewed uniform. Improved. Left skewed Xbavaria. Improved, yes. Left skewed Valmisa. Well, there we go. Made a huge step there. Okay. You know, a big improvement there. Left skewed parasol. Left skewed variable. Alright. Left skewed. Again, behaving much like normal. So, I think this, again, proves that the new evolution scheme is better, in the sense that it will cater to the new requirements, or the new maximum constraint percentage, which gives the new threshold, or the maximum constraint that entities should not go over. So it, with the new evolution scheme, I should be able to, allow, or I should be able to let the entities evolve given any situation, given any other conditions, should the conditions change. I know I still have to, check if that is actually the case in the future. But so far, the new evolution scheme seems to be better. That's all I can say right now. So that's about it. Thanks for watching. I know it has taken me about a month to come up with a new 192 plots, but and that's why I'm actually mumbling and stuttering a lot, because I am ashamed to say that when I look at something, for the first time in a month or in about 2 or 3 weeks even, I forget things. So I'm not proud of it, but it's a good reminder for me to go over this again. So that's about it. Thanks for watching. See you next time. As I'm doing more and more of entity tracking, entity evolution tracking, and it is a whole new can of worms. Wow. I don't think it's basic anymore. I don't think this is, and I think this is somewhere between intermediate and advanced. We'll have to see. Okay, bye.